So let's solve another question on chapter 8. So in this question, there is a airflow which is in steady and incompressible, and then this air is on the large pressurized tank, and we have the pressure and the temperature of the fluid in the tank. And also we know that this is a smooth pipe, so these are also the information about the air in the tank. And also it said that assume that the flow is steady, incompressible, the friction factor is 0.023, and we have the diameter of pipe at different sections. So we have 2.5 from the bigger section and 1.25 for the smaller section, and it said that the minor losses are negligible. Now it asks to find the volumetric flow rate throughout the pump, right? And yeah, let's see how we're going to solve it. So if I want to consider the conservation of energy for that, so first I need to know what is the sections that I'm going to use. So if this one, I consider that one as 0, right? And this pipe right here as 1. So let's say that this pipe is 1. And then if we are going through it, we have 2 here, and then we have 3 here, right? And also it's affiliated to the atmosphere, so we have the atmosphere right here, and I think that's it. So we have the atmosphere right here as well. And now for the assumption, we know that it's steady, it's incompressible, and we also consider the constant properties. Now let's see what is the velocities that we have. So for conservation of mass from 1 to 2, right, we have V1 A1 equal to V2 A2, right? So the fluid is the same, so they are going to be cancelled. And V1, if we solve it, if we write it down, V1, it's equal to V2 times A2 over A1. And we know that A2 over A1, because it's a pipe, is going to be pi T2 pi T2 squared over pi T1 squared. The pi is going to be cancelled, so this is what we are going to have. And if we put all of the values for the velocity for the diameters, this is the relationship between V2 and V1, right? And now if we are doing the same thing for V0 A0 till V3 A3, right, we know that A0 is really bigger than A3, and V3 is less than V0 is less than V3, right? And this one is from conservation of mass also. And then we also have V2 is equal to V3. This is because of the conservation of mass. So now let's write down the conservation of energy from 0 to 3. And if we write it down, this is the formula that we have. So P3 over gamma alpha 3 V3 squared 2G plus Z3 P0 gamma alpha 0 V0 squared 2G plus Z0 HS minus HL. So this is now what we have here, right? And then if we want to just simplify that, so we know that P3 here is P atmosphere, so this one is going to be 0. And then what else we know? So we know that V0 is really less than V3, so we are going to say that this one is also 0. So we have a free jet at 3, right? So then we are going to also consider the uniform velocity there. So alpha 3 is also equal to 1. And I think, yeah, that's it for... Oh, and also the question said that the HS is negligible, right? And then also the Z, all of the, and the pipe, yeah, is in the same elevation. So the Z3 and Z0 is going to be cancelled. And now let's just write it down in a way we can read it better. So we have P0 over gamma V3 squared 2G plus HL1 plus HL2. So HL1 and HL2, right? So this is 1, this is 2, right? Now let's see how else we can just substitute all the value that we have. So if we just consider pi 0 as rho 0 g equal to v3 squared over 2g plus, and hl1 we know that it's f1 l1 d1 v1 2g plus f2 times L2 D2 V2 squared over 2G, right? This is what we have. And then from here, so we have V3 and we have V1, V2. And we know the relationship between V2 and V1, right? And between V2 and V3. So let's just make it more simple and just change V3 to V2, then we're gonna reduce our unknowns, right? So if I do that, I'm going to get V2 squared over 2G plus F1 L1 D1 times, and then instead of V1 we are going to write down the values that we get, and then here is the rest of the equation that we have, right? And now from here, this is the formula I'm going to get 1 plus F1 L1 D1 116 plus F2 L2 and D2. So now this is the the simplification formula that we have. And now for air at a standard pressure, we know that rho 0 is equal to P0 over RT0, right? And if we just put all of the values that we have here, and 10, 1, 3, 2, 5 Pascal, and from here we have 2, 8, 7 times, because it's 2. So now these are the values that we have to calculate row 0, and this is what you are going to get. And now also we can use another method to to solve for and now let's just substitute all of the unknowns that we have in equation 1, and equation 1 is this one. Let me just show it to you. Let me just put the number on it. So this is the equation number 1, and this is f right here. Okay, this is equation number 1, and for just write down all of the value, we know that the pressure is 315, 100, and this is the density of the air, so these are all the values that I have for this question. 6 meter 0 0 2 5 116 plus this is 3, sorry, 0.23, and then plus 0.015 times 6 meter and 0.125 meter. Okay, now we put all of the values, and if we solve it for velocity, the velocity is going to be 27.54 meter per second. This is what we are going to get for that. And now for calculating the flow, the volumetric flow rate, you know that Q is equal to A to A and V, right? And let's say that instead of V, we consider A2, and then V2, sorry, and then for A, we know that it's pi 4 D2 squared. Then this is the values that we have. Squared. So from here, the Q is going to be 0.0038338 meter cubic per second. So these are what you need to know about this question.